any number of the form p by q for p and q are integer and q not equal to 0 are called rational number. Actually we symbolize rational number as q. Okay, so all the whole numbers are rational number because you can write 0 as 0 upon 1, 1 upon 1, 2 upon 1, and similarly you can write natural number also 1 upon 1, 2 upon 1, 3 upon 1. Similarly you can write integer also 2 upon 1, 1 upon 1, 0 upon 1, 1 upon 1, 2 upon 1, and decimal number. This decimal number can also be written in the form of p by q as like 0.1 can written as 1 upon 10, 2.3 can written as 23 upon 10, and 4.467 can be written as 4467 upon 1000. So all the decimal number are also rational number. And last, the fraction are in the form of p by q, so all the fraction are also rational number. Next we discuss all the properties of the rational number. There are mainly 5 properties and one additional property. The first property is closure property. Okay, so closure property means that suppose for addition, if we add two rational number, we again get a rational number, then we say the closure property of addition is preserved. Okay, similarly the subtraction also follow the closure property. Okay, the subtraction of two rational number is again a rational number. Multiplication also follow the closure property, that multiplication of two rational number is again a rational number. But sometimes division does not follow the closure property, because if the second number is taken as 0, then we get a contradiction. That suppose first number is p, second number is 0, then we get a number like p upon 0, which is not a rational number, which is not a rational number. So this is all about your closure property. Okay, the next one is commutative property. So during addition and multiplication of rational numbers, the order does not matter. Okay, so like 2 multiplied by 3 is equals to 3 multiplied with 2, which equals to 6, and similarly addition of 2 and 3 or 3 or 2 is always give 5. But this is not true for subtraction and division. So subtraction of 2 and 3 gives -1, and 3 minus 2 gives 1. So this does not equal. Order actually matter during subtraction and division. So subtraction and division doesn't follow the commutative property, and addition and multiplication follow. Okay, so this is all about commutative property. Our next property is associative property. Okay, suppose star is any mathematical operation like addition, multiplication, subtraction or division. So then the associative property states that A star B star C equals to A star B star C, where A, B, C are all are rational number. And here this associative property is also followed by addition and multiplication, and does not followed by subtraction and division. For example, for this multiplication case, this left hand side equals to right hand side, and for this addition case also this left hand side and right hand side will be equal. But here suppose we take simple integers which are also rational number. If I write 3 minus 2 minus 1 which gives 2, but if I write in this way, this gives 0. So this does not follow the associative property. Similarly for division also, if I divide 3 divided by 2 by 5, okay, I can write this like this. Okay, like this also, 3 divided by 2 divided by 5, which can also be written as 3 upon 2 by 5, and which equals to 15 upon 2. So this 5 multiplied with 3 and it gives 15 upon 2. And if I write 3 divided by 2, okay, and divided by 5, which I can also write then 3 upon 2 divided by 5 upon 1, which I can write also like that. This I take the reciprocal of this 5 upon 1, that is 1 upon 5, and which gives 3 upon 10. So these two values are not equal. So we say the associative property holds only for addition and multiplication and doesn't hold for subtraction and division in the rational number. Okay, so this is all about your associative property. Our next property is the identity property. The fourth one is identity property. So For addition, if I add 0 to any rational number, it does not change the value of the rational number. So this 0 is called the additive identity and it exists for rational number. That is, suppose 1 upon 5 is a rational number and I add 0, or if I add 1 upon 5 to 0, it does not change the value of 1 upon 5. So 0 is called the additive identity. And similarly for multiplication, if I multiply any rational number with 1, it doesn't change the value of that rational number. Okay, so it doesn't change the identity of the rational number. So we say this 1 is multiplicative identity. Like the 0, like for addition, 0 doesn't change the identity of 1 upon 5. Okay, the identity of 1 upon 5 still remains after the operation with 0. So we say this is an additive identity and 1 is the multiplicative identity. And the last property is the inverse property. Okay, so for this property also we can find as like additive identity and multiplicative identity. We have two properties like additive inverse and multiplicative inverse. So for each rational number I can find a contrapositive rational number or opposite rational number such that adding those two rational number gives 0. For example, for 1 by 2 I can find minus 1 by 2 in the rational number set, so adding those two rational number gives 0. Similarly for any rational number, suppose 7 by 9, I can get minus 7 by 9 in the rational number set. This is also a rational number and adding those two rational number gives 0. So here we say the additive inverse of 1 upon 2 is minus 1 upon 2 and the additive inverse of minus 1 upon 2 is 1 upon 2. So for any rational number a, the additive inverse of a is minus a and the additive inverse of minus a is plus a. So here also the additive inverse of 7 by 9 is minus 7 by 9 and the additive inverse of minus 7 by 9 is 7 by 9. Similarly for the multiplication case, for each rational number a, I can get a rational number like 1 upon a such that their product gives 1. Okay, for example, suppose for 1 by 2 I can get 2 upon 1, their multiplication gives 1. Or 5 by 2 I can get 2 upon 5 such that their multiplication gives 1. So here also I can say this 1 upon 2 is the multiplicative inverse of 2 upon 1 or 2 upon 1 is the multiplicative inverse of 1 upon 2. Similarly here also 5 by 2 is the inverse of 2 by 5 and 2 by 5 is the multiplicative inverse of 5 by 2. Multiplicative inverse is also called as reciprocal. Okay, so this 1 by 2 is called reciprocal of 2 upon 1 and 2 upon 1 is reciprocal of 1 upon 2 and this also. So this is all about your 5 properties of rational number. At last we have another law, okay, another property which is distributive property. So we can distribute multiplication over addition or subtraction. Okay, so for example, suppose a, b, c all are rational number. Okay, then I can write a multiplied by b plus c or b minus c equals to a multiplied with b, addition or subtraction, whatever this is, and a multiplied with c. So you can distribute this multiplication over this addition or subtraction. So this is another property of the rational number. So this is all about the properties of rational number. If you enjoy the video, make sure to like the video and subscribe to this channel. Okay, thank you.